scientist. His full name is George Simon Ohm. Here is the setup for Ohm circuit. This is emitter which is used to measure current, switch key, battery, resistor and voltmeter. Voltmeter is used to measure voltage which is connected parallel to the resistor across its terminals. This setup can be classified into two forms. First one in which resistors are connected in series and second one in which resistors are connected parallel.
Definition of electrical resistance. Resistance is an electrical quantity that measures how the device or material reduces the electric current flow through it. The SI unit of electrical resistance is the ohm. Definition of resistor. A device that does not allow electric current to flow through it freely in a circuit.
The current flowing through a conductor is directly proportional to its voltage and inversely proportional to its resistance. Mathematically, it can be written as V equals to I multiplied by R, or I equals to V upon R, or third way R equals to V upon I. Now let's go through the resistance in series in the form of its derivatives and its application, which is shown in the form of an experiment. Resistance in series. In series resistance, we see that the same current flows throughout the circuit, but the potential difference or the voltage will be different. Just see here, the total potential difference V will be equal to V1 plus V2 plus V3. And we know that according to Ohm's law, V will be equal to I multiplied by R. Therefore, V1 will be equal to I R1, V2 will be equal to I R2 and V3 will be equal to I R3. Substitute these values in equation 1. We get IR equals to I R1 plus I R2 plus I R3. Therefore, divide both the sides by I. We get R equals to R1 plus R2 plus R3. It means the total resistance will be equal to the sum of the individual resistors.
Series resistance, in which we already know that same current flows throughout the circuit. So if any one bulb is fused or removed, then other bulbs are affected. Just see, if you remove any one bulb, then others are affected.
Now we will see resistance in parallel. In parallel resistance, we see that the voltage across the terminals are same, but the current will be different. Let's see here. The total current will be equal to I1 plus I2 plus I3. And we know that according to Ohm's law, I is equal to V upon R. Therefore, I1 will be equal to V upon R1, I2 will be equal to V upon R2 and I3 will be equal to V upon R3. Substitute these values in equation 1. We get V upon R equals to V upon R1 plus V upon R2 plus V upon R3. Divide both the sides by V. We get 1 upon R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. It means the inverse of the total resistance is equal to the sum of the inverse of the individual resistors.
Terminals are connected at the same place, but the current passes through different routes. So here, if any one of the bulb is fused, other two lines will not be affected. You can see here, if the bulb is fused here, the other routes are not affected. This type of parallel resistance is used in our day-to-day life, in our home appliances and at home. And series resistance is used in decorative lights.